Hello, yeah. Hey guys, this is Deli from Automata. Really happy to be here at ECC. Also, it's first time seeing so many audience here watching the talk on TEs. So it's really, I guess it's a moment for us. So we are actually building the on-chain attestation layers for like many years, focusing on delivering like Solidity libraries, working with ZK VMs to just do one thing, which is attest to your TEs on chain, or simply put, verifying the code that's generated by the machines. So we actually work on many different stacks, Intel ones, also AMD, AWS Nitro. We touches basically all of them. Work very closely with cloud providers. Also, we have bare metal machines, so we know how to really deploy those even on bare metals. So earlier this year in East Denver, I also gave a talk on TE's adoptions. At that time, I wouldn't really believe that there are people like really love to exploit it, but I think today I could really say that we've seen a lot of adoptions. As we walk through the talk, you will also see like a lot of new ideas like around using like TE to help Ethereum to reshape its future. You must see the news that like L2Beat, the website that lists all the rollups, are starting to reassessing and also recategorizing all the rollups, and some are actually losing the like rollup states, which is the maybe the kind of the top signal, because we've also seen rollups start being shutting down, being phased out. It's really kind of a milestone to say that maybe Ethereum already kind of answered its initial scaling question. But again, it's also something that we should focus on the next stage because there are still other issues here. Like I already listed like three like different aspects. These are somehow intertwined together, not really independent. It's really hard to like put them in a nice way, but this is kind of the best effort. So I will be talking about like scalability with composability, and also the meaningful privacy, and lastly the provable speed and also fairness. I think in the end you will know that maybe TE could be the solutions for some of this. So first, the composability issue. I think it's kind of inherent when you start doing rollups, because you create like different states, different chains. It's all these technical differences, but also you create like difference in terms of market growth or market shares. So that's really hard to have like coordinations between different like chains, different rollouts, because those big players wouldn't really mind like just winning more, right? They could just stop like doing any meaningful like collaborations with other chains and still maintain its advantage. And also another thing is the cross-chain transactions or messaging are still quite slow. I think part of the reason is it takes time to withdraw from layer 2. And then and it's like the reason is kind of multifaceted, because you have different type of rollup. You have like ZK rollups. You also have optimistic rollups, which have longer like withdrawal period. So all this actually become one kind of big challenge, which is the kind of the entire ecosystem is not really scale up and preserving the so-called like network effect as a whole Ethereum ecosystem. So that's something we need to solve. And the second part is it's actually not a new issue. I think it's already there since the very beginning, because it's like blockchains are transparent layers. But there are still some meaningful protections we can provide for users, which are not in place today. For example, some are really highly demanded features or apps that we should promote or we should build. I think Vitalik mentioned a couple of them, like the payment privacy issue, which is, I think, kind of fundamental, because you don't really want people to see your billings, right? See your spendings every day. Secondly, I think we don't really have some good defaults. For example, all the on-chain activities are somehow linked together, because you ended up using maybe just same wallet across chain, across apps. You don't really have kind of a per app protection. For example, if like if you are using Apple, they provide this kind of like email relay, right? So you could just sign up using different address for different services. But I think there's no such default here. The only way is to maybe you try to memorize so many different seed phrases or create so many wallets and try to maintain the mapping yourself, which is troublesome. And also some other things, including the RPC at the RPC layer. You're probably gonna be surprised that you're actually giving out a lot of information to the centralized providers, including your intentions, including your identities, because those data that you send over, even if it's a query, it can review your identity or be linked back to your other kind of devices. And also, I think, lastly, the network level information, there's no really good choices to protect unless you're expert on like shielding your kind of connections to the internet. But that's not something that average people could use. So again, like I think a meaningful privacy really means that something that users could easily pick up and use without having to worry much about it. And last one is the kind of provable fairness and speed. I think when we talk about fairness in Ethereum, I think the first thing come to mind is actually MEV. I think it's been a nightmare for many of the users, also debt developers as well, because you don't really have good solutions. You either have to sort of bribe the validators or you just completely fall victim to it. And also, in terms of speed, because of the delays you see in those withdrawals, you really have to wait, and this results in longer delays when you try to do cross-chain actions, which really interrupt the user experience a lot. And because of all these things, it's really hard to create real-time apps, for example, the games or even like messaging apps, sort of things. I think people are already thinking about kind of making faster confirmations, even the block time is still longer. So in the end, I think some good defaults here are like we should really provide kind of protected mode so that user get to enjoy the benefit and without having to worry about all these things. And yeah, I think in the past we've seen that we've tried solving the issue using maybe some mathematical solutions or just based on social trust. But I think now maybe we can look at DE because it's actually changing the game. I think in the next slide you will see like a lot of projects using it. But now I'd like to just mention a few things, maybe also the key reasons people are choosing TEs. First of it is actually the performance, because a lot of logics are kind of hidden behind the hardware. It's inside those circuits, and it's being offloaded in hardware so that it can execute really fast. It's kind of the same logic that when you have, if you offload some of the ZK operations to like circuit to hardware, you will get a lot of performance gain. But the story of TE here is these are really just special mode made on top of CPUs or in a way that entire package of the hardware so that you could have some sort of isolations, encryptions, for example, encrypted memories. You could have access control so that each trust domain is not able to talk to each other. I mean, all these are really hardware primitives that you don't have to worry about. You could just really gain near native performance because somewhere when you cross the trust boundary, you still get a performance penalty. And second thing is on the, it's really kind of controversial because somehow it's becoming alternative to other mathematical solutions, or maybe a better word is complementary, right? Because if you choose a hybrid solution, very often it's working better, surprisingly better. And you will get the benefit of both. And also, right now, compared to a few years back, the technology is definitely more widely available on clouds, bare metals. You could easily get the TE machine running at your home. Actually, if it's possible, all your laptops would have this kind of functionality. For example, Macs. But the unfortunate thing is they are not opening it up. They're not allowing people to make deployments to those secure chips. But once they do, it's actually going to be very powerful. Then lastly, I think it's also quite important to say that compared to a few years back, nowadays you have VM-based TEs. You don't really have to worry about changing your code base, making kind of adaptations or making glue layers so that it will work with TEs. I think based on our experience working with other projects, they could really just focus on like shipping the code, making it work in the TE environment, and we will help them to take care of the attestations, take care of the verifications, or even advise them on like making right choices on like security policies and stuff. So this is, I mean, all these things kind of contributed to the adoptions of TEs. But of course, we have to be careful, which is something everyone is trying to remind us of, which is the assumptions or the security compromise you're trying to make. You really have to trust the hardwares in terms of like all the things, right? The manufacturer, like the fabs, and also the software packages, the firmwares. Like if it's VM-based, you probably have to trust the kernel as well, bootloader kernel, like even TPM modules. But I think a good thing is these are kind of part of the supply chain anyway, because even if you do other technologies, it's inevitable that you have to have a way to, you have to choose your base, right? You have to choose where is your foundation of the trust. So if this is the state of the art, I think we can take it first, then use it with care, and also try to understand more, and also like there has been like security experts working on fixing those issues. There will be also more exciting development on new hardwares. Maybe it's open sourced, maybe it's fully audited, so that you can like trust hardwares just like you trust the code. So here's actually slides I've spent some time to put together. I intend to use logos, but in the end, I think text is more efficient, so I can put more here. But even though I couldn't like put everyone here, so sorry for those who didn't make it to the slides. You can see that a lot of rollouts are now using TEs. It's probably not using it for the foundation of the security, but it's using it as a, for example, 2FA solutions, or as a way to increase security. Because strictly speaking, using running things on TE is actually strictly better than not running it on TE, right? And also we see like Flashbots really leading on this MEV space, doing block buildings, or even layer 2 block building, the rollup boost framework. And also we've seen teams from like new construct, they're doing the new order flow layers, try to compete with them. And at interop, there's protocols trying to address those issues, trying to make things faster, shorten the confirmation time. Wallet and key management, I think these are people who really believe in hardware, because they've been using it at the very beginning. Even at the time, it was just Intel SGX or Nitro Enclave, which is way harder to work with. And of course, recently, since last year, there has been really a lot of development on verifiable AI based on GPU TE. As of now, it's probably just referring to the one that NVIDIA has, which is H100 or H200 series. And ZKVM, you might be surprised that they're also using this for 2FA purpose, or for private approving, because you don't want really let the prover node to know your input, right? So in those cases, you could use TE to have some isolation, to have some security. And also web proof, I think TLS Node3 is actually using, is running their Node3 server in a TE. And also lastly, Word ID, they're also, we're working with trying to make the, trying to let the run the MPC protocol initially in GPU, but now working on CPU as well. So these are really kind of surprising adoptions. Some of them are actually new compared to my talk at East Denver. So yeah, so also along the way we have some key patterns observed. For example, TE is actually used as a more cost-efficient solutions or cost-efficient 2FA for those things. And building applications is becoming kind of straightforward as well. Many teams are even hiring engineers to do so. You have nowadays you have VM-based TE, which is more preferable because it's easier to work with. And also, we didn't see this coming because Nitro is also getting attentions. People are using it maybe because of the existing deals with AWS, but that's also kind of a big part of the like developing your tech. And we've seen more complex security models being built. People are trying to let multiple parties have their code running inside the same TE so that they could work with each other or compete with each other. And also a very important key pattern is actually the on-chain attestation, which is a thing that we're working on. So the kind of the concept behind this is really simple. You simply just take the code generated by all sorts of TEs and put it on chain and just verify it following the same protocol that you would verify maybe at the offline environment. So we spend a lot of time making the kind of port the code, for example, the Intel verifications into Solidity, which is the first step. But after we've done this, we realize also many like partners also help us to realize that it's too expensive because you have to process a lot of data, which includes some of the search, some of the collaterals that comes together with the attestation. So in the end, we provide the kind of alternative solutions. We work with ZK VMs so that we could kind of offload those expensive solutions into a prover, ZK prover. Then on-chain, we just need to verify the result, which is more efficient and has less footprint on-chain. In the end, I think very often you could achieve maybe many orders of magnitude improvement in terms of the cost. Of course, you have to pay the cost of ZK proving, but I think in conclusion, it's often like cheaper than just running everything on-chain. But again, that means you are having additional dependency on ZK VM. For many of the applications, maybe you're still gonna choose kind of the native one. And I'd like to also give a few updates regarding our kind of open source libraries and some products. So this is actually the maybe the kind of state-of-the-art on-chain testing libraries for Intel, SGX, and TDX. It's support, like I said, Solidity and ZK-based attestations. Actually, there has been over 700K ZK attestations, ZK verifications on chain. And also it supports the V3 and V4 version. V5 version is coming soon. We've spent time developing it and also getting the machine that support V5. Also, we're trying to add Solana support. And actually, a funny story, during the development, we actually hit the heap issue because the Solana program have a limit on the heap size. We have to find some work around it. And second thing is actually also maybe a highly wanted feature because people who work on the decap stuff is also kind of be bothered by all the collaterals. You don't really know where to find it. You don't really know how to update on chain. So we built this dashboard, which is a new service we're gonna release soon. So this dashboard, you could easily track all these collaterals on chain and try to scope out the FMS SPCs that your machines have, and also trying to see all the activity logs to have some transparency. So currently it's still in beta, so please reach out to us if you'd like to have a try on it. This is some sneak peek of the kind of dashboard. You could see the like the ongoing monitoring and also the activity logs. And also we will be providing functions like automation so that those certs will be renewed automatically. Yeah, and over here it's the, some of the SPC stuff that you can control. And what's next for us? So we're actually trying to like make more progress, make the developer experience better. We're doing a new VM image that would support both Intel, TDX, and AMD. so that as a developer, you could just ship your code. You don't have to worry about the environment difference. We will take care of the difference and as well as the on-chain attestations. So in the end, you just pass data to your machines and you will really get the result on-chain. Also, we have a new wiki launching, kind of community effort with other TE projects. All right, and don't forget to check out other TE talks at the ECC. These are really good ones. I think that's everything for today. Happy to take some questions. Thank you. Yeah, so the question is, where do we store secret? So actually, as the SDK developer, we don't really want to dictate on that. There are many different choices. If it's short-term secret, it's better to just keep it in memory. If it's something that you really have to seal and put it on disk, then I would suggest maybe like you could either develop your own sealing and unsealing like SDKs, or you could really use the kind of the like disk encryption option provided by TPM, because those are really transparent. You don't have to worry about that, and it's kind of full disk encryption as well. Yeah, these are totally off-chain. We don't really recommend putting stuff on-chain because who knows if like quantum compute will decipher those things or not, right? That's it, yeah. That would be everything. We probably don't have time for another one. Thanks.